Hey everyone, we're going to talk about while loops today in this video. While loops allow us to repeat code blocks over and over again, however many times we'd like them to. Um, so, as I've mentioned in previous videos and in class, programs run top to bottom. We can run certain code when we want to based on uh, if and if else structures essentially, right? So if we can meet a certain condition, we can run a certain code block. Well, if we want to repeat code, whatever codes we put into a certain code block, we can use a while loop to repeat that however many times we'd like. So first I'm going to start out with what a while loop kind of looks like here. I have it already typed out, but I figure I'll just retype it. So you start out with the keyword while, and you have your parentheses, which checks a condition. If it's true, then it'll keep running the code block after it. So the entire program that we wrote in the last video, we could stick that entire program inside of this code block and have it run forever over and over and over again, which we'll do at the end of this video. So in here, the easiest way to read this is while whatever is in these parentheses are true, this code gets run. So in C, any value other than 0 is thought as to be true. So while 0, this is false, would not run this code at all actually. So if I put a -1 though, it will run this code. So let's do a quick sanity check. I'll comment, or I'll just delete this for a second. Let's do if -1, then printf true. And then else printf false. Okay, so whatever this is, if this is true, it runs this code, otherwise it's false. So just to show you, -1 means true in C. I'm just going to run this code. And there it is, true. So now I'm going to change it to 0. This should be false. There it is. Give it a positive number, show you that it's true. And let's give it a letter, or a character. True. So anything other than 0, anything in here other than 0 is true. If it's a 0, it's false. Hopefully I said that correctly. Okay, let's get back to the while loop. So I can delete this, and this reads while whatever is in these parentheses is true, run this code block. So I'm going to do printf hi there, and we'll just put a 1 for true. So while true, run this code. So I'm going to run it. I don't know if you can realize this or see it, but it's still running, and it's printing hi there over and over again, nonstop. It's not ending. So I just hit Control C to kill the program, or you can just hit the X. That works too. So notice, if you want this while loop to stop, you need to somehow get this expression to become false. So now we're going to talk about the idea of iterators. If you want to run it a certain amount of times, or if a user enters in invalid input, you could repeat the code until they enter in valid input, which we can think of as setting a flag to true or false, which the while loop relies. So now we can, let's just start with iterators. So say we want this while loop to run 5 times. Well, something needs to either count up or count down. Luckily, we have variables that we can adjust the value to. So easy enough. I guess I should put this under the example. I'll just push this down. let's just declare an int, and I'll call it CNT for counter, CNTR for counter. I'm going to start it off at 0. So now, the while loop, we're going to be checking to see if counter is a certain value, or if it's reached a certain value. So as long as this statement is true, run this code. Okay, so let's just say, let's see, if counter is equal to 0, run this code. So think about what's going to happen here. I'm not going to say anything. Now I'm going to run it. And of course, it is now in an infinite loop and will run forever. So this condition is true, but we haven't changed the value of counter. So we need to actually increment the value of counter or decrement it. But this expression also needs to change. So let's just say, as long as counter is less than 5, then run this code. I'm going to run it, and there it is, the infinite loop again. The whole idea behind this is important, but if you're not changing the value of the variable that's being checked, then it's as good as still broken, right? So we need to change the value of counter. Well, inside of here, we can take the value of counter and assign it it's the value of itself, which right now is 0, and then add 1 to it. When we add 1, it'll go from 0, so this is 0, and then add 1 to it, it'll be 1, and it'll store it in counter variable. So when it comes up, it'll say, is 1 less than 5? And for sanity checking, I'm just going to print out the counter value. And since I have a placeholder, I need to give it the variable I'd like to put in that place. So now, when we run the code, counter starts out at 0. It says, is 0 less than 5? Then yes. Then run this block of code. It then prints out counter is 0, and then it adds 1 to counter. So when it comes back up to here, it'll be 1 now. Is 1 less than 5, etc. And it'll print out 1, then add 1 to it, it'll become 2, and run over and over again. So let's see how this goes. So there we go. Counter 0, 1, 2, 3, 4. As long as the counter is less than 5, run this code. As soon as counter turned to 5, though, this became false. 5 is not less than 5. Thus, it did not run this block of code, and it kept going on its merry way and returned to 0. Okay, so that's the idea with what's called iterators, and I'll write this out. Iterator, or a counter, something that iterates, right? It adds. So let's say we want to go the other way. Say we want to subtract. You can start the counter off at 5, and you can say if the counter is greater than 0, then run this code. So I'm going to run that, and how does that go? Well, that doesn't look good, right? If the counter is greater than 0, which is true right now, 5 greater than 0, then it's going to run this code. Whoops. So the logic is kind of there, but unfortunately, when we're changing the counter, we're adding upward, right? We need to subtract. So it counts down. So it'll go 5, 4, 3, 2, 1. And it shouldn't print 0, right? Because 0 is not greater than 0. And there it is, 5, 4, 3, 2, 1. So just pay attention to where these numbers start and where they end. And you can adjust those values accordingly with greater than or equal to, greater than or less than or equal to. So I'm going to put an equal to, so I want to see 5, 4, 3, 2, 1, 0. And there it is. So that's just a quick way to show you how you can control how many times you want to loop your code. And then you can count up or count down. So there's another way of actually writing these while loops. So while something is true, I usually like to just put a 1 in there as a placeholder so it doesn't give me the red squiggly line. We can create I'm going to comment this out real quick. We can create another variable that I like to call exit, which is just it's an exit flag. Exit, the word exit is actually a keyword in C, and so I just use exit in its place. So with exit, what I was saying was before, anything in this parentheses, as long as it's not a 0, it'll run that loop, right? If it's 0, it's not going to run at all. So I can initialize this to be a positive value, right? So if I do this, exit, if the code is just written this way, the code starts at main. Exit is set to 1. So while true, run this code. So on this little exercise, we'd like to write some code that will prompt the user over and over again until they enter in the correct values, which in this case, we're going to do values 0 to 100. So this will go along with the in-class assignment for the week. We're going to do a little thing where they enter in a value 0 to 100, and it'll spit out the representative letter grade. So this way, the program doesn't just end when they enter in a bad value, right? You want to keep prompting the user over and over again to either, hey, if you want to quit the program, then type this. But if you don't want to quit the program, then you need to enter in some valid values. So I'm just going to write here, valid values are 0 through 100 inclusive. So including a 0 and including a 100. So first we want to prompt the user. Enter in a value between 0 and 100. So I need to store their input somewhere. I'm just going to go ahead and write the scanfs part. I'm going to use ints in this video, but you should use floats, or floats would be good for accuracy, I guess, or a higher precision. Let's see, and we'll do what will we call this? We'll call it grade, and don't forget the ampersand. Call it grade. We'll start it out at nothing. Doesn't matter because we'll have it set on the user input right here. Okay, so the first thing we want to do, check for invalid input. Okay, how do we do that? Well, we can use if statements. So if the grade is what's out of bounds, anything less than 0, right? Less than 0. If it's less than 0, we're going to say printf, please enter in a value between 0 and 100. You entered, and then print out the value they entered. Grade. Okay, great. Also, if the grade is larger than 100, right? Greater than 100, you can give them the same message. And we'll discuss in the next week about these logical operators where you can do a double check like this. This is an OR. If the grade is less than 0, or if the grade is greater than 100. But we'll get into that another time. So it'll check this for the correct value. It'll check this for, invalid value. It'll check this for an invalid value. Now, if it makes it past all 3 of these, then it must be good, right? So if I can treat this like else, right? Else printf you entered D grade. This else only connects to this if, not to this one, right? So if we want to check in a chain-like fashion, we can just do else if, right? If this isn't the case and this isn't the case, then run this code. Now they're all connected to each other. You can have white space after here. That's up to you. Okay, great. So we have all these checks, right? We have all these checks. Now what? Well, remember, we're in a while loop here. We need to exit this while loop. When do we exit? Pause is there for you to think about it, right? So when do we exit? Well, we exit when there's good. They've entered in a good value. In that case, a good value is down here. So we need to change the value of exit such that it evaluates to false. And with what I just said, everything is true except for 0. So we can exit this loop, this while loop, when they've entered in a good grade, or a grade that's between 0 and 100. And we change the condition by setting it here. So let's give it a try. All right, enter in a value between 0 and 100. -1. Please enter in a value, blah, blah, blah. You entered -1. See, so it prompted me again. So I'm going to jump back here real quick. When the program ran, started from the main, then it went exit is set to 1. So while true, exit is true. While that's true, prompt the user, store their input into grade. Now check to see if grade is less than 0. So in this first case, I said grade is -1. So it gets into this top if here, prints that out, skips the rest of these, hits the bottom, and starts from the top again. Exit wasn't changed, so it says, is this still true? Yes, it is. So prompt the user again, and that's where we're at right now. So now let's do 101. So 101 is stored in grade. This is false. It goes here to check. 101 is greater than 100. So it prints this out, skips the else, hits the bottom, comes back to the top. Once again, exit hasn't changed, therefore we're at the prompt the user. Now let's give it a valid grade, a 99. So grade is 99. 99 is not less than 0. 99 is not greater than 100. Therefore, it gets into here, tells me I've entered in 99, sets exit to 0, hits the bottom, comes back, and says exit is 0. So while false, do not run this block of code. So it exited out and returned and ended the program. Now we have the logic for the code that lets us rerun a certain block of code over and over again until a user enters in a value we'd like to see or we'd like to work on. So in the in-class assignment next week, you're going to, as mentioned, create that program that takes in a numerical value and spits out its representative letter value. And so if you're entering in values that don't mean anything, well, we want to just throw those out and keep asking to see if that's, or keep asking until they enter in something valid so we can actually give them a letter grade. All right, finally, I'll pop open the other solution from the previous video. Let's see, I think it's this one. Okay, looks like it. So now we want to run this code over and over again. They enter it in. I'm going to zoom out just so you can see the shape of it. The top of the code is here. The first set of code that actually prompts the user to enter in stuff begins here. So what we're going to do is we're going to take everything after the declaration and we're just going to put it in a big while loop. So I'll do it right above the comment. So while something is true, run the code. I'm not going to close my bracket. Instead, I'm going to zoom out a little bit and go all the way down to the bottom of the code. Okay, so before the return 0, but after everything else, I'm going to put a closing bracket there, tab it over, and just for my own little thing, I'm going to just tab everything over so I know that it's inside the while loop. You probably can't see that in the video. Okay, so this should run the code over and over again until I hit those the exit button. So, but notice, I just put while 1 there. I didn't put exit, I didn't make an exit flag or anything like that. So let's just do something like 4. Okay, great. It calculated it. Now it's asking me, please enter in a numerical value. So this is just, it started over from the top. So if you look at the top of this, we're back to here again. So 25.0 and then 43, and we'll do addition this time. Great, we added it together. So, but this time, I'm going to exit out after I give it the 2 numbers. So 33, now I'm going to hit 0. Notice, it ended the program. It said goodbye, press any key to continue, and it's closed. So why did that happen? Just a quick refresher going through the code. When you enter in an invalid input, it's going to return 0. That means the main function, it says, main function, we're done here, return this value, which essentially ends the program. So when we get to the menu value of 0, where is that? Right here. We return 0 here. This exits the main program. So I didn't need to create an exit flag. It's if you're just going to kill the main program. So that's another design decision. And we'll talk more about this in class and let you guys get some practice.